I can start anytime. I can start anytime. I'm good. Are you guys recording?
Yeah. All right. We are about to get started for the Brainbase workshop. So if anyone is interested, it's right now. Also, let's give a round of applause to this guy, Alexei. He's actually adding another access point for you guys, so we make sure to have internet, and he's very quiet, but he's making this event possible as well. Hey, Alexei. Good job. Okay, great. So everyone here, we are ready to get started? Yes? Okay, let's do it.
All right. All right. Good to go? All right. Hello, everyone. So we'll do a quick Brainbase workshop for anyone who wants to use Brainbase in their submission for the hackathon. So we'll do a quick overview of what Brainbase does, what our agent framework is different in, why people use us, and we'll go over a quick demo example of what it looks like in production. How do you put it into production? How do you actually use it? We'll do a toy example, and then we'll share you the documentation, and then the guides and sample projects over Slack. All right. So Brainbase, our main goal as a company is to make sure that companies are able to build their own AI agents. We see that buying is better than building in a lot of cases, and we see IT to be the gateway to AI. So we're seeing that in the next year, companies will be producing more of their workforce through AI than through their actual hiring. So this is the future that we're trying to enable. What we are in this, where we fall is we are the first of its kind enterprise agent platform, EAP, that's a term we coined, which means that we're a holistic platform that the IT teams can build all of their workforce from sales, marketing, customer support, all of that out, and connect it to all of their third-party apps, all of their internal APIs, documentation, and then deploy them omni-channel to phone, SMS, Slack, wherever you have. So this is kind of how you create your agent through a template, customize it, deploy it. Some of our customers include Toyota, NBC, people doing thousands of chats. And
you slow down a little bit? I'm trying to read this.
These parts?
Yeah.
Cool, all right. All good. Some of our customers include Toyota, NBC, Hard Rock, and hotel chains, airlines, whatnot, who are doing a lot of use cases on us. We are seeing that we are 83% faster to deploy compared to building it yourself. And in the last year only, we've saved and generated $97 million of workforce opportunity for our customers with our 8,000, now around 10,000 agents built and deployed production. So that's kind of the spiel about the company and what we do and what we tell to enterprises, but you guys are all devs, or mostly devs or so. So we want to go through what is different, what is differentiating about Brainbase. To do that, we need to go back to what makes an agent. So what we've identified to make an agent is what we call the Brainbase Diamond. It's 4 components and 4 components only. If you look at any agent in the field, these are the only 4 components that it essentially has. These are database, which is a structured database, documents, unstructured documents, audio files, whatever you have, integrations, a way for it to access tools, and then the intelligence, which is usually the LLM. So when you look into the field, you see that all 4 of these components individually are essentially solved. So you have your MySQLs, Postgres for the database, you have your PDFs, whatever, MP3 files for the unstructured documents, S3 buckets, LLMs already coming from OpenAI, Anthropic, and then the integrations you just build out or use like a model context protocol server. What we're seeing is the interesting problem here, what differentiates a good agent from a bad agent is how you connect these 4 components together, how you actually make them together. What's happening in the field right now, what normally people are using, is that they're actually using the LLM to connect all of these together. But that is very inefficient and actually is not as performant as you might think. So thinking of creating an agent with OpenAI API just from scratch, This is how you would essentially set it up for chatting. You would be able to add streaming to it. You can make a conversation. It keeps going up and up just for a simple ability to do Google search. So this is what you have for Google search, and we haven't deployed it. This is not being served anywhere, and it's still a very big undertaking. In production, we see that agents require a lot more than a single tool call and need a lot more reliability checks and a lot more, gatekeeping to build. So it becomes a very infeasible thing to do with just regular LLM APIs to use to connect these 4 components. So we decided that we need a way of creating AI agents that's stateful, serverless, and reliable. So you should be able to access information you uncovered in previous steps without having to run that through text and getting it back through text tokens again. It needs to be serverless. It should be so simple that when you deploy an AI agent, you should be able to click a single button and it should provision an agent in the cloud, and you should not have to deploy servers for each of these actions, each of these tools that you're using, and it needs to be reliable. That is the biggest thing when you're putting something in the field. All right, so to that end, we built what we call Based, which is the assembly language for AI agents. This is what you'll be using today if you are going with the Brainbase track. This is what we call an agentic instruction markdown language. This is a first instance of that. This is coming from my PhD work, and it's something that we built the company on as the core technology. So in this technology, how it works is that the example that you saw before turns into this, which is a set of instructions that the AI will follow. So what you do here is you say, here's the conversation, talk to the AI, talk to the user by saying you're a help assistant, and you can search Google, have the conversation, and then exit that once the user asks you to search something on Google. Then go ahead and call a sub-agent using the .ask to understand what the user asked for, and then do the Google search functionality built into the agent without running any servers, and then return the results back to the agent. And then you're able to go ahead and deploy this to the cloud with these simple 4 lines. And more so, you can also go ahead and deploy this over multiple channels, just the same. So in these, a total of less than 20 lines, we were able to get a Google search agent up and running and then deployed to a phone number. So that is the power of Brainbase, and that is kind of what we'll be experimenting with today. So first of all, before we go into the workshop, I encourage people to sign up to the sandbox. So we'll share this link. I think a lot of you already signed up to use Brainbase.com or use Brainbase.xyz. So that is our enterprise client, so you won't be able to work on that. This is a sandbox environment we made for the hackathon. This is a place where you can sign up. You don't have to put any credentials in terms of credit cards or any billing. You should be able to go in and get started. And this has the ability to do voice deployments and chat deployments, which is what we're expecting you guys to use today. So I'll give everyone around 30, 45 seconds to just get on this if you're trying to sign up. It should be pretty simple with email, and then you should just be able to verify your email and get going. All right, so let's move on to the actual demo of a toy project. So for the toy project, what we wanted to do was to create a bot that you can essentially ask Pokemon questions, and you can ask hypothetical Pokemon questions of who would win in a battle. So this is an example of something you can build, and we'll show you kind of how this was built and run you through it. So if you go into our client, once you start, you will not see any workers here. You'll just be able to go ahead and create a worker. So when you click Add New, you just need to be able to name the worker, and then you can leave everything as default and then go forward. So let's go into our worker here. So our workers consist of, so like we said, there's 4 components to a worker. There's the flows that it has, which is the underlying language. There's the resources, which is the unstructured and structured data, and then the integrations are in the previous homepage where you can connect your tools. So let's see the flows that we made. So the very first, the default flow that you have when you start is going to be this. So this is our editor view. So on the left, you'll be able to edit your based agents, and then on the right, you'll be able to preview how they work and be able to chat with them. So this is a very simple one where you just say, there's an AI that's going to have a conversation with the user, and then whenever they say they want to stop, it is going to say goodbye and then leave. So let's try this out. So it's sending me, hello, how can I assist you today? I'll say, how's your day? It should be able to go, thank you for asking, I'm here to assist you. So it'll be able to continue the conversation until I say, I want to stop. And then at that point, it is going to get out of it. So it's going to call that the node has changed. So it's going to go into this section, and then it's going to say goodbye. And then it's going to finish. So the reason you're seeing these messages is so that you can debug these when you actually want to implement it on your own client. If you want to use chat, but you want to use your own UI, you will have access to all of this information, and we'll show you how you can use it. So the more interesting example here is, let's say if you wanted to talk about a Pokemon. So here in this example, we start by saying, welcome friend to the Pokemon helpline. Let's see how we can help you. So whenever you want to say something deterministic, you can go ahead and use our say. And then if you want this to be exact, at the end you can put exact equals true, and it will be saying verbatim what you're putting in. This is very good when you want to confirm something, when you want to summarize information after doing some actions. After that, we're going to say, okay, our first agent is going to be talking to the user about Pokemon. We're going to say, you can either give information about a Pokemon to the user, or you can compare two Pokemon and tell which one would win. And then whenever they ask about a Pokemon and give the Pokemon's name, it is going to call a sub-agent using .ask. So .ask calls sub-agents in Brainbase, where unlike the regular LLM, OpenAI LLM, where you do the function calls and it has to put all the parameters in the function call, here it decides where to go, and then any parameters we need, we call it by calling on a sub-agent. This makes it a lot more reliable on getting those parameters out of the conversation. So we'll just say res.ask, return the name of the Pokemon the user named, and then the example is Charizard. It's going to say, let me see about that Pokemon, and then it's going to go into this Pokemon API and get the results. So the nice thing about Brainbase is that you don't have to have an external server about this. You can just put it directly here. You don't need to run anything on the cloud. You don't need to write any more code to do those API calls. You can just put it all here, and it'll be able to do it. We parse the Pokemon information, and then we give it to the next agent saying, here's some information I found, and then you can keep answering users' question about this. So we'll go ahead and start this. Let's see. So hello, I'm here. This is your Pokemon related questions. Do you need game strategies, whatever. We'll say, I want to know about Charizard. All right, so it said, let me see about Charizard, hang on a second. So now we're waiting, and then now what it did in the back end there is that it said that, and then it went and fetched all the information about Pokemons, the Pokemon we're talking about, and then it was able to give the stats, weight, types, all of that information. So now I can ask, so what type of Pokemon is this? Charizard dual type Pokemon, both fire and flying, so you can keep going with this information. The important thing to note is that the payload of this API call is normally very, very long, more than 130,000 tokens. So if you were to put this in LLM, you would not be able to feed back the entire API. So you would have to have some form of server that essentially takes this and then truncates it and then puts it into LLM. When you use something like Brainbase, we're able to only get the important parts that you want, which are the stats, the weight, and the types. So that helps with actually keeping only the information that you need in this conversation. So the latest iteration of this flow is going to be how do we make them compete. So now what I can do here is I can go in further and I can add another sub-agent that if you instead want to battle two Pokemon, you can go ahead and say, okay, who would win in a fight between these? So this works just the same. You just say, user wants to compare two Pokemon and gave both of their names. It goes ahead and fetches both, and then it talks about who it thinks would win And then once you're at this stage, this sub-agent will essentially keep giving you information based on those two Pokemon. So this one I'm not going to demo over chat. What we're going to do instead is one of the powerful things about Brainbase is you can essentially, once you create these flows, the agent itself sits external to the actual deployment that you do. So the same agent you create, you can then go ahead and deploy to chat as well as voice as well as SMS. So you create one agent and then you can use it wherever you want, which is one of the most powerful things you can do with an agent because now it becomes like a remote worker, a human that you can talk to. So to deploy this, what we've done is we've gone into and create a new deployment on this phone number that we linked. And then these are some of the previous calls that we've done. So I'll be able to give this phone number a call and we should be able to have a chat with the Pokemon bot we just made on voice as well.
Welcome, friend, to the Pokemon Helpline. Let's see how we can help you.
Hello, I wanted to know about Charizard.
Hey there. I can help you with information about a specific Pokemon or compare two Pokemon to see which one might come out on top in a battle. Since you mentioned Charizard, I can give you more details about it. Let me know if you'd like that or if you want to compare it with another Pokemon.
Yeah, let's just, so you just give me information about Charizard.
Let me see about Charizard. Hang on a second.
I'm waiting. I don't know which flow I connected this to. Hello? All right, let's try it again. I did it for someone just earlier. I don't know which one I connected it to.
Supposed to work over there. It wasn't supposed to work over
Yeah,
here.
obviously, yeah. All right, let's try it again.
Welcome, friend, to the Pokemon Helpline. Let's see how we can help you.
Hey, I wanted to get some information about a Pokemon.
Sure thing. I can either give you information about a specific Pokemon or compare two Pokemon to see which one might come out on top. Which one are you interested in? And this information, just let me know the Pokemon's name.
I want to know information about Charizard.
Let me see about Charizard. Hang on a second.
Any information? Yeah, I think it's struggling with getting the name of Charizard to be spelled correctly. So you're able to fix that by going in here and making sure that it spells it in lowercase by telling the sub-agent. But essentially, you're able to have the conversation and do the exact chat flow on the voice here. So you can kind of refine your prompts and make sure that it works in production. So we can go ahead and see what that looks like on the logs once you've done it. So if you go here, you'll be able to see the actual transcript of it. So here, so it was able to say, let me see about Charizard. Hang on a second. Most likely what it did is it put Charizard with the C capitalized, which the Pokemon API most likely doesn't take. So you would be able to go ahead and fix it just like by doing lowercase on the Python or telling the sub-agent to generate in lowercase. That's probably a thing that we didn't catch in building this. So by looking over these transcripts, you'll be able to refine it. I'll show you some of the flows that we have working in production today. So these are kind of example simple flows. So here's one that is actually a production flow that we have out in the world. Yeah, so for example, this is one for a dealership where it is able to go ahead and fetch customer information every time we call. And then if they have an account, get the information about their vehicles on the account. If they don't have an account, actually create one and then move forward and book an appointment and give them information. So this is sort of how far you can take it. The reason it becomes a better thing to work on is that now it goes less from a magic problem to more of an engineering problem where you can see exactly at what line the AI is saying what, and then you're able to go ahead and debug it. You're able to do CI/CD on all of this and do version control and whatnot. So here, if you were to deploy this in code, you'd be able to go ahead and write up a .base file. So we have an extension that allows you to syntax check .base files. And then you'd be able to create a deploy.py file using our SDK, where you'd be able to create the flow and do exactly what we did on the client, create the voice, and then be able to make outbound calls or be able to make inbound calls that can be called on the phone number. So that's kind of about it. And we'll be going around helping people out with their deployments. And finally, I'll show sort of what our docs look like. So our docs are going to be at docs.usebrainbase.com. So here you can see the REST APIs and the SDKs. So these allow you to do everything you do on the client. So you'll be able to use them. You'll be able to generate an API key for yourself from your client by going to settings. So you can go ahead and generate an API key if you want to use it through the client. And then for more advanced features, you can go ahead and check our guides. So we'll be able to share these with you. And then you'll also be able to use the WebSocket for chat. So this is for cases I think someone mentioned before where they want to use the system on their client. So they want to connect to it from their front end. They want it to have custom functionality. So that's something that you can do here by creating custom functions in the system that, so in the flow code, what that allows you to do is you can go ahead and define a custom function that you can call in your flow. Let's say custom battle. And then you'd be able to pass in whatever you want here. And then you would be able to get it back in your WebSocket client and then process it and give it back to the agent. So it allows you to increase kind of what the agent can do on your platform as well. So this is a workshop. This is the end of the workshop. So we will be answering questions going around. If you have any questions, feel free to come to me or anyone else from the team. And then I'll put the phone number here that we just called. And you guys can feel free to call it and see if you guys get better luck. I'll make the lowercase change in a second so that maybe that'll fix it. But yeah, let me put it here as well.
Maybe if you could throw it in the Slack, that'd be super.
Yeah. I'll be able to throw all this in Slack, and I think this is also recorded, so you guys will be able to watch it later at your own speed. And yeah, feel free to ask any questions. We're happy to help. But yeah, all right. Best of luck to everyone.